Number 27, we need to get in simplest form, right? So we'll prime factor to do that. So 3 times 3 times 11. So 3 out in front, 11 on the inside. We'll have 3 square root 11. 28, again, we will prime factor. The y to the 4th. So we'll have a 5y squared that comes out in front. And that 2 will be left over inside. 29, which can't be simplified. So pretty straightforward off the bat. We know that D is going to be able to be simplified. They already match. Okay, B, if we checked and we tried to simplify this, we couldn't get those to match. So this is going to be the one that cannot be, right? If we went here and we checked the others, we would eventually be able to see that they would be matching. Okay, so our correct answer there is B. 30, we're going to multiply. So we multiply things in the same location. So 30 times 10 is 300. And then we need to simplify. So we'll have a 2, a 2, a 5, and a 3. There's our pairs. 2 times 5 is 10. Square root 3 is left over on the inside. Number 31 is already in factored form. So we just need to set each of those factors equal to 0. So we can say 6x minus 5 equals 0. And x plus 7 equals 0. Solve each of these. It's going to get a little bit squished. So we'll get x equals 5 over 6 and negative 7. 32 is a quadratic. It's not in factored form, so we can solve it with quadratic formula, completing the squares, solving by factoring. I'm going to do this one by factoring because we have some other options coming up. So multiples of negative 5, that will add up to negative 4, right? I can choose 1 and negative 5. And once I get it factored, I can set those both equal to 0 because they already equaled 0 to start with. So I'll get answers of x equals negative 1 and positive 5. 33, we want to find the values of a, b, and c. So this is really right, 3x squared plus 0x's minus 17. So a is going to equal 3, b is going to equal 0, c is going to equal negative 17. 34, I'm going to pick another option here. We can solve with different options. I'm going to do the quadratic formula on this one because we have some others coming up. So if we do a is 1, b is 3, c is negative 24, negative 3 plus and minus, square root of 3 squared, minus 4 times a times c, all over 2 times 1. So again, then we'll evaluate underneath the square root. So we get square root of 105 all over 2. We would need to check and see if we can simplify this. We cannot, so this would be our final answer. $35, what number would we add to make it a perfect square? That's going to be our steps of completing the square. So right, 12, we'll take half of that, which is 6. Squared is 36, so that's the number that we would add there. 36, again, I'm going to choose completing the square on this one so I can sort of show all the different options. You could choose quadratic formula as long as you set it equal to 0. Okay, your answer should be the same in the end. So we'll find b, we'll take half of it, we will square it, right? That's what we're going to add to each side. 14 plus 16 is going to give us 30. We'll factor the left-hand side, It's always the middle piece, so that's a positive 4. Then we'll square root. So that will give us x plus 4 equals plus or minus the square root of 30. We could check. We cannot simplify the square root of 30, and it's not a perfect square. So we'll just solve from here. So we'll get x equals plus or minus the square root of 30 minus 4. If you did the quadratic formula, you might have negative 4 plus or minus the square root of 30. You would just need to recognize those options in multiple choice. 37. Uh-oh, the answer sort of got flipped to the next page. Sorry, guys. So if we look at 37, which of the following equations describes the graph to the right? So we need a to equal 1. And this has a vertex of what? Negative 5, negative 6. H is always the opposite. So we'd actually be over here at A. Guess it's okay that I've like to see the next page. Start the next video.